Hi students, in this video we are going to see how to convert an Epsilon-NFA to a DFA. In finite automata, there are two types of automata, deterministic automata and non-deterministic finite automata. So in deterministic automata, in a state for a single input, there will be one transition, whereas in a non-deterministic, a single input may have more than one transition. An automata with epsilon moves, that is a move without any input, is said to be Epsilon-NFA. So in this particular video, we are going to see how to convert an Epsilon-NFA to DFA. We'll be using the same derivative subset construction method what we have seen in NFA to DFA conversion in our previous video. So let's go to the sum. So this is a given Epsilon-NFA. So we are going to convert this Epsilon-NFA to DFA with the help of E-closure concept. E-closure concept also you can see it in my previous video. So first, for simplicity, I just drawn the transition table for the given diagram also. So here in this Epsilon-NFA, we have like one start state and two final state, that is Q4 and Q3 is our final state. So while we are converting an NFA to DFA, we'll be having the same input like 0, 1, 1 and set of final state and set of initial state as with respect to our NFA. And as per the subset construction method, if we have like n state, there may be chance that we may got 2 to the power of n states in our DFA. Okay, so how to start the problem? So first, we need to find the epsilon closure of Q0. That is epsilon closure of your initial state. So epsilon closure of my initial state is so Q0 itself. So from Q0 it goes to Q1 and Q2. So Q1 comma Q2. So now this is my new state as per subset construction. This is my new state. So let me name it as A. Let me name the state as A. Okay. So now instead of finding the epsilon closure for all the state, we will go with the new state. That will be easier. So for this new state, what happens if the input 0 and 1 comes, we will see. So our new state is actually Q0, Q1 and Q2. So in our Q0, Q1, Q2, that is delta cap of. Delta cap is missing over here. So this is actually delta cap of Q0, Q1, Q2 would be our E closure of delta of U closure of delta of Q0, 0 union delta of Q1, 0 union delta of Q2, 0. So this is our subset construction concept actually. That is E closure of delta of Q0 with respect to 0, Q1 with respect to 0 and Q2 with respect to 0 we need to find. So here we reduce it. So in Q0, Q1 and Q2 with respect to 0 we have like Q4 and Q2. Am I right? So it is E closure of set of Q2, Q4. It is Q2, Q4. So we need to find the E closure of Q2, Q4. So let me find the E closure of Q2, Q4 here. Let me use this as E closure table. So E closure of Q2, Q4. So E closure of Q2, Q4 is again union of E closure of Q2 and union of So E closure of Q2 union E closure of Q4. So what is it actually? So from the diagram, E closure of Q2 is from Q2 with the E doesn't goes anywhere. It is simply Q2. Likewise, E closure of Q4 from Q4 with an epsilon as a Q4 thing, it doesn't goes anywhere. So it is simply Q4. So epsilon closure of Q2 comma Q4 is simply Q2 comma Q4. So let me write it as Q2 comma Q4. Okay, actually this is going to be my another new state. Am I right? This is going to be my another new state, and let me make it as B. Now it's also we won't forgot it. So let me make it as B. Okay. So likewise for 0 we have find it for Q0, Q1, Q2. In same way, we need to find for this new set Q0, Q1, Q2 what happen if input 1 comes. Same way. Same union concept, where here instead of 0 we will be finding it for 1 with respect to Q0, Q1 and Q2. So in Q0, Q1 and Q2 when the input is 1 it goes to simply Q3. So it is E closure of Q3. E closure of Q3. So what is E closure of Q3? Let me go back here. So E closure of Q3 would be, so in Q3 state there is no thing. So it is simply Q3. So it is Q3. Okay, well? Okay, fine. So now we got a new state Q2, Q4. So for this Q2, Q4, that is B, we need to find what happened with an input 0, 1, 1 with respect to 0, 1, 1 for Q2, Q4. So Q2, comma Q4. Likewise here Q2, comma Q4. So in Q2, Q4 with the what we have to do again, same symbol representation. U closure of delta Q2 with respect to 0 and Q4 with respect to 0, what it comes. Q2 and Q4 with respect to 0, it goes to Q2. Q2 and Q4 with respect to 0, it goes to Q2 only. So simply E closure of Q2, Q4 which is Q2. So Q2. So what is E closure of Q2? We have find it already? No. So let me find it already. So E closure of Q2 is, U closure of Q2 is simply Q2 itself. So Q2. So now it is simply Q2. Okay, wow. So now Q2, Q4 with respect to 1. So the same transition with respect to 1. With respect to 1, we are going to find Q2 with 1 input and Q4 with 1 input. So in Q2 with input 1, it goes to Q3. Here it goes to Q4. Q3, comma Q4. So it is epsilon closure of Q3, comma Q4. Epsilon closure of Q3, comma Q4, which is a new state, I think so. We haven't find it again. So epsilon closure of Q3, comma Q4 will be Q3, comma Q4 will be epsilon closure of Q3 union Q4, which is equivalent to epsilon closure of Q3 is simply Q3. So Q3, comma epsilon closure of Q4 is simply Q4. So it is going to be Q4, and this is going to be your new state. We can name it as C now. For this also we need to find. See, it has been converted automatically. Okay. So this is now C. So which is Q3, Q4. So let me write it as Q3, comma Q4. Okay. So now I got another state Q3, Q4. So I need to find it for Q3, Q4. So yes, you may ask, okay, when should I stop it? Until you are not getting any new state, you have to do this again and again, iteratively. So Q3, comma Q4. So here again, same way, I need to find. So let me copy paste it. So instead of 2, here I'm going to write it 3. Here instead of 2, I'm going to write it as 3. So here it will be E closure of what it comes Q3, Q4 with respect to 0. Q3, Q4 with respect to 0 is simplified. So I don't need an E closure at all. It's going to be 5. That's it. And epsilon Q3, Q4 with respect to 1. Q3, Q4 with respect to 1 is going to be Q4. So E closure of Q4. E closure of Q4. I think E closure of Q4 is simply Q4. So we can write it as Q4. Okay. So I hope we haven't got any other new state. Am I right? So we have got this state, and this state, and we have handled all those states. And do we have any other new state to check on with? We don't have any other new state. I think we can tabulate it. So before that, here you can see that we have like Q3 as one state, Q2 as one state, and Q4 as one state. So to remove the epsilon, we will better what we can do. We will find the transition with epsilon closure to remove those things. So we will find the epsilon closure of for 3, 2 and 4 we will find. For 3 with respect to 0, what it comes we will check. Same way 3 with respect to 1, what it comes we will check. Same way for 2 also, because it is came as one of our other state. For Q2 also we will find. And let me and also with respect to let me paste it here. For 4 we will find. Okay, let me merge the cells so that I can write it here itself. So what would happen? So with respect to delta Q3 0, in Q3 it is 0, it is 5. So it is simply it's going to be 5. And with respect to 1, in Q3 if it is 1, it is going to be 5. So only I haven't given more space and all. I know it's not required. With the Q2, with respect to 0, it is Q2. So it is epsilon closure of Q2. So epsilon closure of Q2 is already we have find it here. So it is Q2 only. So no issue. Whereas Q2 with 1, Q2 with 1, it is Q3. So E closure of Q3 will be equivalent to E closure of Q3 will be equivalent to Q3. See, already we have find it. So it is Q3. And for 4 with respect to 0 and 1, 0 it is simply 5. So let me insert the symbol 5. And for 1, it is Q4. So E closure of Q4, which is equivalent to E closure of Q4 is Q4 only. So it is Q4. Okay. So now what we have to do is that we need to tabulate all the answers. Okay. So we have like here A, B, C and 3 and 3, 2, 3, 2 and 4. So what we are going to do is that this is the final solution answer. You have to make it as a NFA state, DFA state, and we have only two inputs 0 and 1. So let me take the first state what we used. So here the first state what we use is this one A. So NFA state is Q0. The NFA state is Q0, Q1 and Q2 where we name it as A. Correct? So here with respect to 0 and 1 we got it as Q2, Q4 and Q3. Q2, Q4 and Q3. So this is going to be Q2, Q4 and this is Q3. Let me rename it afterwards. So Q2, Q4 and Q3. The another state is new state what now? Q2, Q4 which I name it as B. So here Q2, comma Q4 which I name it as B. So here with respect to B, so this is my let me shape so that you may think. So this is my A. Same way this is my B for B which I have formed it, and this is my C. This is my C. That is the new state. Okay. For Q2, Q4, that is for my B, it is Q2, Q3, Q4. So it is with this here Q2, Q2, Q3, Q4. Q3, comma Q4. So again I got this new state Q3, Q4. So Q3, comma Q4. I name it as C. And with respect to Q3, Q4, when it is 0 and 1, it goes to 5 and Q4. So you just insert the symbol 5 and Q4. 5 and Q4. Okay. So here I got this Q3, Q2 and Q4. So let me make it as Q2. And do I have any other new state? No, I don't have any other new state. Only Q2, Q3 and Q4. So Q2, Q3 and Q4. So for Q2, Q3 and Q4, I'm not giving any name. So for this Q3, simply it's going to be 5 and 5. So let me copy paste it. Okay, with Q, so that is for Q3. For Q2, I think here it is Q2 and Q3 with respect to 0, 1, 1. So Q2 and Q3. Then for Q4, here it is. It's for 0, it's 5. This is Q4. So 5 and Q4. Fine. So now we have another important task. If you want, you can name it as A, B, C, sorry. You can name it as D, E, and F. This is just a name convention. So now I just transfer the name over here. So Q2, Q4 means here it is B. So this is going to be B. Q3 is actually here it is E. So you can name it as E. Q2 is here it is D. So it is D. And Q3, Q4 is C here. So we will name it as C. Q4 is F. So I name it as F. Q2 is D. So simply D. Q3 is E. So simply E. And Q4 is F. So simply F. Now I need to say which is the initial state and which is the end final state. So from this NFA diagram, we know that Q0 is the initial state and Q4, Q3 is the final state. So in this set, wherever Q0 comes, that becomes your initial state. So this is going to be my initial state. So you just put the symbol arrow, and Q3, Q4 is my final state. So wherever Q3, Q4 come, make it as a final state. So this is one of my liable final state. This is also one of my final state. Then this is also one of my final state. And this is also one of my final state. So here what happened is that let me write the formal definition for my constructed DFA. So my DFA D will be having like first is capital Q. Capital Q is set of state. So what are the states I have here? A comma B comma C comma D comma E comma F. So these are the set of state. After set of state, I will be getting input. So I have only two input, that is 0 comma 1. So after sigma, that is Q sigma, I'll be having delta. Delta is my transition. So this is my transition. So let me just put the the transition symbol. Okay, fine. Delta. Then my initial state. Here my initial state is A. So inside the bracket itself, let me put as A, and my final state, that is set of final state. So here's final status. So here also we can make that arrow mark symbol, and the final state over here is star. B is one of my final state, C is one of my final state, E and F. So let me mark it as my final states are B comma C comma E comma F. So these are my set of final states. So this is my DFA. So you can see that in my NFA, I have like how many states? 4 states. In my converted NFA, I have like 1, 2, 3, 4, 5, 6 states. I have my 6 states. So this is the conversion of epsilon NFA to DFA conversion. I hope you have understand this concept. We'll see in the next video. Thank you.